financial entities like Microsoft. And where this will take us will be very interesting, where not just the visual sense is important, but predictive intelligence, bringing contextual information to us, and the way in which we interact with that information through natural interfaces is just as important.
Okay, so let me start with a question. Imagine you are in a room doing your stuff and you suddenly hear this sound. What would be your reaction? What would you do when you hear this sound if you're in a room doing your stuff?
Okay.
Exactly, so
Yes.
that's what I did too. This was 15 years ago. I opened the door, but no one was by the door. Heard the sound again, opened the door, but no one was by the door. And it took me a while to realize that the sound actually came from my Yahoo Messenger. If you remember back in 2000, Yahoo Messenger played this alert when a contact came online. So now it may appear stupid that I opened the door for that sound, but it made perfect sense to me back then because that was the first time that I started using a computer. So my natural and instinct response to a door knocking sound was to open the door. This is just one example, but in general, keyboard shortcuts, all these other mouse interactions were totally alien. They were not built to facilitate us. We had to learn a whole new set of skills to be able to use the technology. So in a way, technology made me feel disabled. And I remember, anyways, I took my computer practical exam where we had to write a piece of code in a given time. And I could write down the algorithm on paper pretty quickly, but it took a while to find keys one by one and type it out. Time ran out, and I failed my first practical exam. And it also gave me a chance to realize that there's a huge potential if you could develop intuitive human-computer interfaces. Because computers has become a part of our lives. I mean, not just this keyboard and box version, but all these other smart devices that we use pretty much as a computer. So why can't we make the interaction with them very seamless? I'll give you a very simple example. If I ask you to copy something within a computer, I mean, now I know I can do right-click, copy, right-click, paste, or keyboard shortcuts. But if you didn't know this, then you will feel kind of disabled how to do this. But if I ask you to move a physical matter from one place to the other, even a kid can simply do it. There's no learning, it's built into our natural behavior. So I was asking myself, can we make this moving data between devices very seamless? I come from a Southeast Asian background. We have this traditional activity called tilaka. Basically, it's a process of creating a colored mark on your forehead. You have colored powder on a plate, you take it with your thumb, put it here, and it's a very seamless way of moving physical matter from one place to the other. Why can't we move digital matter just like that? So back in 2011, I did a project at MIT where we could move digital data just like physical matter. So I just grab that phone number, drop it to my phone, and it gets copied over. If I needed to give a movie to my friend, I grab it and I drop it to my friend's phone. There's no learning, it's built into my natural behavior. To explore further into this, we coined the term assistive augmentation. Technologies that built into our natural behavior and allows us to do things beyond what we think we could do. This is now adapted by my Samsung, and it's a Samsung software product called Samsung Flow. And I also realized that I felt disabled by the technology. Similar to that, there are other people who felt disabled by the technology. sometimes we think, disability is a physical condition. That may be true, but technology also plays a part of making people disabled. At MIT, there was a friend who took a class with me. He was blind. He uses a smartphone app to get his things done. But I could observe, if you were to use a smartphone app, you need to find the phone, unlock the screen, browse to app using voiceover feature, then open the app and then take a picture. This was a very cumbersome process. And this was not because he didn't know how to use a smartphone. This was because this state-of-the-art technology makes him do lots of overhead work every single time. So we came up with an assistive augmentation, the finger reader. Basically, it's a finger-worn camera that allows you to point at things, and the camera sees what you're pointing at, recognizes, and have the information translated back to me. So with this, my friend could walk into MIT Corp, recognize how much money he has by simply pointing, point at a price tag. It will tell him, what's the price of the item. Then he could decide if he has enough money to buy that thing. Or could walk into the library, recognize what are the books on the bookshelf, and pick the book of his choice, and then read it line by line. And basically, all we did was simple augmentation of taking the camera out from the mobile phone, put it onto finger. But it was very powerful for a few reasons. One, now you completely cut off that overhead of having to find the phone, unlock the screen, all that set of steps. Secondly, our natural behavior is to point at things and ask questions. Now my finger reader augments that behavior, gives you more information. And thirdly, my fingertip act as the reference point. So you could try closing your eyes and taking a good image with mobile phone, which is a very difficult task, but with finger reader, I can feel the object, use my fingertip as the reference point, and take a good image. So it was powerful. And because it is built into our natural behavior, the use cases goes beyond blind users. It could be a tool for kids to bring beautiful colors and textures from nature into digital devices. And my daughter uses it for learning. She's reading a book and then she's verifying what she reads is true, because finger reader also reads things back to her. And useful tool for, especially for me when I travel. I wish I have this when I'm, especially in Japan. I don't read Japanese, so I needed this to translate things back to me in English. The possibilities are endless, and I should be done if I just think of an academic point of view, because we have had our patents, papers, lots of media visibility. But my passion and vision is to really bring this out to the people, and I'm working with government agencies in securing funding to make few thousand pieces and then distribute to the blind communities in Singapore and beyond very soon within this year. And we have had great ambassadors in Singapore giving feedback about this product. There's a blind professor in NTU, Dr. Wong Meng Yi. He was sharing his experience with finger reader with BBC.
Now, you used the finger reader. What do you think of it?
I think part of the challenge in using the reader is the dexterity that is needed for a blind person to move across the page, for example.
Right.
So that can be a little bit tricky for persons who may not be able to move in a straight line. So something that is seemingly simple for a sighted person, but I think if we can move towards helping the user gauge what is a straight line, I think that would tremendously help the user in time to come.
To help people with visual impairments follow straight lines, the user's finger feels a vibration to guide them along the text, an example of haptic feedback, and that's in the process of being perfected.
So there's still challenges that we have to overcome, and we are bringing this proof of concept project out of the lab and trying to do the entire design for manufacturing process and bring it to a product. And right now, this is the version we have. It's small and easy to wear, but this is not yet ready to be given out to people, but this is what we are working at right now to really do the final touch-ups for this so that it can be a product that enable blind people to access visual information. So I've also done work with people who can't hear, and we were exploring, just like people who can hear, how can you also enable people to be aware of interesting sound events. And we designed this little device called stick ear. Basically, it's an extra ear that you can stick it anywhere and you can be aware of sound events. So to my knowledge, I know hearing impaired people, they use multiple products. You have a special doorbell to be aware of if someone is by the door. You have a special alarm clock. You have a special device to know whether your microwave is done. So and the other challenge is first challenge is you have to have multiple devices. The second challenge is when you travel, these accessible things won't travel with you. Your home may be accessible, your workplace may be accessible, but when you travel, stay in a hotel, that place may not have all these things. So we wanted this device to be a simple thing that you carry with you and become your environment accessible. And we work with the Deaf Association in Singapore, and with their feedback, this device was designed. And last year, again, BBC came down and they were interviewing some of the users who use this, and they were trying to explore and understand, what was the potential of this device.
The stick ear, which gives visual alerts to people who have difficulty hearing sounds, such as a knock at the door or a telephone ringing. So let's put it to the test. I'm meeting Jia Yi Lin, born deaf. She's agreed to help us demonstrate the stick ear in action.
I'm going to go and stick the stick ear on the door, and I'm going to knock it and see if you'll let me in. So just give me a sec. Great. So it worked. Thank you. Was that helpful?
It's good, yeah, it's definitely helpful. It doesn't need to depend on me, a hearing person, to tell her that the door, if someone is knocking on the door, she can see it on herself.
Right. So do you think this is something that you can see yourself using? This will be helpful to you in your life?
Definitely, yes. For example, at home, if I don't want people to come into my room, I can always lock it. And then after that, if maybe I'm doing my work or something, when I see the lights flashing, and then I'll open the door and let them in.
The stick ears aren't just for people with hearing impairments. It can also be used in noisy environments to alert people to fire alarms. So as well as improving lives, they could also save lives.
So basically, it replaces of you having to use multiple devices. You can attach it back of the door. You will be alerted when someone is by the door knocking on the door. You can attach it to your regular alarm clock and have your mobile phone vibrate when the alarm goes on. You can attach it to your microwave when the food is ready. You can have your mobile phone vibrated. And unfortunately, we could not get our crowdfunding campaign fully funded when we tried last year. I don't know, maybe our marketing was not strong enough. But I now see a similar product came on Kickstarter. Just overnight, had 250,000 over dollars. Now it's over $1 billion. So I'm hoping that at least that will take off. Our plan with this is we are making a small batch production, about 50 devices. The World Federation of Deaf Conference happens October here in Singapore, and the plan is to distribute this as a door gift so that at least small group of people can benefit with this. This is another project that we concluded last week. Singapore Deaf Sports Association approached us. They were running the second National Deaf Games. Right now it is running. They wanted to have a swimming event. What they wanted is to have a visual alert for deaf swimmers to start on time. This is what's out there existing. You have this light that goes on when the ready signal is given. But this has many problems. One is it's on the side. You have to look the side, and then when the ready signal is on, you have to jump in front. So not the best design. And it only flashes when the ready signal. So there's no anticipation. So, and then if you have different types of events like backstroke, this is not useful anymore. So we came up with a new design, which is this, that gives you anticipation, as well as it is adjustable to the comfort of the swimmers. And it is fully compatible with what Singapore sports school uses. So for the technicians, it's simply plug and play. They didn't have to learn anything new. This was in use last Saturday as part of the national swimming event. So when they had backstroke, they adjusted accordingly. When they were doing freestyle, they adjusted accordingly. This is one of the events. You can see when it is ready signal, this lights up in orange and then turns green. So it was satisfying to see, small things that you do in the lab really going out and making an impact on the lives of people. Two more projects, since this is about Visual SG, I wanted to touch base on some of the visualization projects we did. We did few large-scale public light installations as part of iLight Singapore and other events together with Philips Singapore. So these were meant to be interactive installations where public could go and interact. This is done at the Marina Bay Area, 1200 lights that reacted depending on how people move around the pier. This is the reed bridge that connects Clarke MRT with Clarke Pub area. This bridge kind of indicated the energy level of the bridge, so depending on how people move, how much they move, how loud they speak, the lights change. This was on show for a month last December. Then as part of the SG50 event, we did visualization in front of the boat quay in front of UOB Plaza, where we created a map of Singapore, where people could go and send a birthday message, and the map reacted depending on your location. And it allows people to, kind of visualize where they are within the map, and also the over time map evolved into a heat map where it had, brighter, more intense colors for the district who wished the Singapore the most, and the district who didn't wish that much was, less intensive. So last but not least, another project that I want to touch is previous speakers talked about AR and VR being, coming into the play. But one of the challenge is, if you want to play with AR, the more natural way would be to, play with your hands, right, rather than touching the touch screen on the back. That's not an intuitive way of interacting. And we all know this is a natural way. And we all know there are gesture recognition technologies, but the challenge is all these, Microsoft Kinect or Leap Motion, any of these things would not work here, because these devices does not have that much power, they don't have that much processing. So we tackle that problem in a more technical way, where we came up with a new gesture recognition technology that consumes about 100 times less power than what's available in the market, as well as the data rate is about 1,000 times less. So now doing something like this on a VR set is realistic because of the technology. This is how it works. Even you can play a first-person game on a smartwatch, because our technology consumes that much less energy and that much less data. And this is now being brought over by Samsung. So the next Samsung Gear VR set will hopefully have this technology built in. So now they're in the process of taking this over from my lab, and also with my employees going over to Valley.
Avengers.
Yeah, so these are few of the projects that we do at my lab, Augmented Human Lab at SUTD. And I also want to touch base on what Gary mentioned in his presentation, all these new technologies that keeps coming in. One thing that worries me is, it's nice to have all these technologies. They all meant to make our lives better. That's the intention of the design. At least that's what we think the designer's intention is. But the challenge is, if the interaction with these are too difficult, or if you have to learn something totally new to interact with these things, it may make you feel disabled, just like how a personal computer made me feel disabled because I didn't know how to use it. So what I believe is that, as a community, as researchers, as educators, as practitioners, it's our duty to try and think of ways of encapsulating the technology such that it operates implicitly in the background while enhancing our human-to-human experience in the foreground. And we need to adapt this idea of assistive augmentation, making things seamless, simple and enabling as we develop next generation of technologies, devices, systems, processes and even policies. Because that will enhance the way we work, live and play, and also will help us stay human. Thank you.
Thank you, Prof. Suranga. Next up, we have Professor Isaac Curlow. He's a filmmaker and one of the pioneers of computer animation.